Hello, I'm Philip Stoten. I'm here at Productronica 2019. I'm on the Scoop studio. I'm joined by two gentlemen to discuss the opportunities and challenges around the rollout of 5G. We have Ross from Indium. Thanks for stopping by, Ross. And Alun Morgan, who is from EIPC, but also from Ventec laminates. If I could start with you, Alun, what do you see as the big opportunities around 5G, first of all?
Well, I see it as actually an enabler. The 5G is a kind of fabric that can help us move forward in a number of different ways. And I think the thing to think about 5G as opposed to 4G is the technology and what it really delivers. So, for example, the latency is a massive difference. So latency we see on 4G is probably 60, 70 milliseconds, something like that. We can get down to 1 millisecond with 5G, and that makes things happen in real time. So whereas we were talking about doing things on the edge before, we can do them in the cloud more because we do have that connectivity. So I see that as being pretty important. If I would think about, for example, autonomous vehicles, we have big challenges, autonomous vehicles, with how these communicate with each other and with other vehicles. If you can get down to latency of 1 millisecond, you can do this actually in real time. So that will be an enabler for that kind of move. Think also about Internet of Things. Think about this massive billions of devices connected together. Think about the industrial Internet of Things as well. Think about medical care. Think about all these things that we want to connect more and more with. So two things matter. One is the bandwidth, but one is the latency. And if you can really get the latency down to this 1 millisecond, it really works. And I saw a great demonstration from Ericsson in a football stadium using virtual reality headsets. They had 4G headsets on, so they were actually seeing the whole field from their headsets. And they couldn't play football, because the time they got to kick the ball had already gone. The goalkeeper couldn't get the ball. They then switched to 5G. So their vision of the field came through a 5G relay, and they could play football completely without seeing anything. They could play it, and that was a very graphic demonstration for me. It was from Ericsson as well, who told me they'd already shipped around 3 million 5G radios, by the way, which I was very surprised about as a number. So I see that as being the most exciting thing about this. So the technology, of course, I love, and I love this new rollout and what it means for us all. But actually, I think the function of this will be something rather more than just another network of connectivity for us. There'll be another enabling of other technologies and other solutions for us moving forward.
Yeah, and I think it's fascinating as a building block. I was at CES, as I always am at the beginning of the year, kind of finding out what the key trends are. 5G was kind of top of mindset, and it was an enabler for everything you talk about. Smart cars, but smart cities, all those kind of things, bandwidth, latency, the ability to do mission critical computing in the cloud is absolutely amazing. And I think what's also interesting is it creates some smart factory opportunities, which I'm excited about as well. When you look at it from your point of view, Ross, it's exciting in terms of what it can deliver, but it's also creating opportunities and challenges for you as a material supplier.
Absolutely. There's many new materials needed for as 5G rolls out. You look at the front end modules for the mobile phones, or really right now they're using these communication modules in cars everywhere, and so the reliability requirements for them requires new materials. The pitches and the dimensions in the front end modules, the system and package heterogeneous integration requires a whole new class of solder pastes, a whole new class of fluxes, and then there's also opportunities even in the base stations. There's need for silver sintering. There's need for new thermal interface and thermal management solutions. There's different kinds of even the processors that are doing all the computations on the signal. So it's not just the RF signal. It's the back end of the processing around that signal that needs to be handled, and that's all new ASICs. So there's an enormous amount of materials and new products coming out to enable 5G.
Yeah, and what's interesting when I think of your position, Ross, is you've got to get in front of this. You can't be hanging around waiting for companies to come and say, hey, we need this solution. You've got to be ready when your EMS companies or whichever vendors you're working with come to you with that requirement. How do you do that? How do you stay almost ahead of your clients' requirements?
Well, one of the great things is working with leaders. When you work with the best companies in the industry, you have the mavens that are in those companies that are really trying to think out in front. And then we have a saying at Indium, from one engineer to another. So we bring our engineers to our customers, do road mapping and engagement at their sites to try to understand where they're going. So, for example, we have Type 6 materials, which is which is high volume right now. But there's Type 7, Type 8 materials that are coming out to enable, again, the system and packages.
Yeah, and when I look at that from your point of view, just switching your hats to your Ventec hat, you've got to be in that position with the laminates. You've got to be ready for the bareboard manufacturers to say, hey, we need these signal speeds, we need this, and this, and they're not going to wait for you to develop it. You've got to have it there ready to ship.
It's massively exciting as well, because actually the other thing that we talked about, the hardware there and what's happening, the cell size is much smaller for 5G than 4G, so we need far more cells for a start. That means far more materials. So that straight away makes us smile. Yeah. And actually, I was in Taipei 2 weeks ago, and there are factories in Taipei now making laminates who are full. They're already rolling out materials for 5G, and it's being used. So they're really running around trying to get more capacity to bring these materials out. So I think that is really very exciting indeed. And of course, there are challenges here. Of course, there are challenges on the technology side. But if you think about the smart cities, for example, in urban solutions, this is going to be really transformative. I have my concerns around the rural solutions, by the way, because the cell density is going to be really difficult to get.
They won't be able to afford it. I don't know if you saw the analysis, but it's going to be trillions of dollars if they made everything, the phased array antenna 5G, right? They can't do it. No. It's just too expensive.
So that's going to be an issue. But I see in urban living, it'll be transformative completely. Absolutely. And never mind the latency bump we talked about, but actually the number of cells and the coverage will be far better. And coverage is something that we want to have. We want to be connected all the time. And if you, like I've lived through dial-up modems and where we are today, this is incredible for our lives actually, and what difference it can make. So as a material supplier, there are challenges, and actually one very important thing as well, which we shouldn't forget, is the technical challenge of producing these circuit boards. Never mind the assemblies, because I was talking to Ericsson not long ago, and they're saying basically we need to halve the tolerances of everything, halve them. Because actually we cannot accept the variability that you're delivering on the materials on the boards now. We have to halve the tolerance. So that, because we're talking about up to 70 gigahertz, something along those lines, 70 gigabits per second. This is a big challenge away from 4 or 5, a handful of gigahertz, going up to 70 or so. And actually everything becomes more important, and the scale of the feature size becomes more important, and the variability of that feature size. So I think there's a big challenge ahead. So it's nice and easy to say, we're going to roll this out, it's all going to be easy. It's not going to be easy at all. No. There's a lot of challenges in there, and I think you've already mentioned some of them from your side. But I think the materials and also the PCB fabrication have to really take this on board as well, and actually understand what they must do. Yeah. And there is a roadmap, I think, already for where they need to be, and manufacturers need to move down this path, really ready to roll out. Certainly one thing we are seeing though, we see infrastructure already coming along. We haven't seen the handsets really coming along much either for smartphones, but the forecast I've seen, I'll just give a presentation from Walt Custer, and we're talking around 2023, we're talking about this becoming really mainstream. So we have 3 or 4 years before we see the handsets mainstream, but actually next year will be the big rollout of infrastructure. So it's already happening, so we have to be ready now, we have to really be working, and there are capacity constraints as we speak.
Yeah. And Ross, when I look at it from a point of view of specialist materials, are we going to be in a situation where there are 5G materials and other materials, or eventually are we going to bring all materials to the standard that meets 5G? How's that going to work in terms of differentiation? When I look at, for example, the lead-free thing, everything changed and eventually all the materials moved across. Is it going to be the same with 5G?
I think the benefits that we're getting as we migrate to 5G materials also create benefits in backward proliferation, right? Once you hit the milestone, then you can bring that back. So, for example, high electrochemical migration and inhibition or stopping that from happening in these devices becomes really important. So you have, let's say, a low standoff QFN, which a lot of these have. Well, you need to make sure you don't have a wet residue around that can conduct. Because any of that, like you were saying about the switching speeds and the powers, it just amplifies all those problems if you have any. So you need these better materials. Once you get those better materials, you can of course bring those back into 4G, but other assemblies like industrial electronics and automotive electronics can benefit from those same materials.
Yeah, and I think that's the thing that we see in these. When we start to close down those tolerances, you initially do it for specialist materials for a particular product, but eventually you end up with tighter tolerances on every material.
I think on the PCB side that will happen because the manufacturer have to be capable, and when you're capable you can do it for everybody. It's not by selection. It cannot be that way. It must be capability. On the material side, though, so the base materials, putting my Ventec mindset to this, from Ventec's point of view, we have to produce materials which have a lower dissipation factor and dielectric constant. This is essential for design and also for loss. But of course, on the other hand, we also have to deal with the heat dissipation because we have high power devices now as well. We really do. And we have these MIMO, we have beamform, we have many, many features on these systems we don't have currently. So all that will also benefit other industries too. So the developments we're making now in handling that thermal management as well will help elsewhere. So I think that will move us up. It'll step us up the ladder for everybody else as well. But we certainly won't be supplying, let's say, all materials with the low loss that we need for 5G because we don't need that elsewhere.
And it's not economic.
There's always a compromise. It can be an economic compromise, it can be a technology compromise. There may be other factors that don't play out so well. So I think we have to be also very selective. We will certainly not find a universal solution that solves all the problems. We'll find a multiple set of solutions for the different issues that we face. And I think 5G brings one set, but I definitely believe that the reduced tolerances will be something that benefits the whole industry.
Yeah, great. Especially across big boards, right?
Exactly, because it really matters.
These massive boards, if any stretch or any expansion causes a problem, both for the board assembly, but for the alignment and also stencil printing. So the pace need to be better across that whole large board. It creates a whole new dynamic. So we've been working hard on better stencil life products because it's a longer stencil life, better printing on large apertures and small apertures because you have this complexity on these boards is enormous. And then of course low voiding also, because any voiding causes thermal issues.
And feature size is also pretty
really
fine.
dynamic.
I was talking actually with Jan Pedersen of Elmatica just earlier on today about the way the industry will be going, and we talked about sort of single piece flow in manufacturing of PCBs. And it is possible now to optimize the process per panel. You know, I was at Unimicron's plant last year. They measure every single panel, copper thickness, and they can adjust the etching per panel.
Fantastic.
You can adjust the solder mass production on an inkjet per panel. So this is a concept that may come along. To get that tolerance down, rather than just a batch process, we will actually take an optimization per panel, and it can be done now. Industry 4.0 can deliver that, by the way.
I was going to say also, that's a 4.0.
And it's a bit circular because you perhaps need a 5G to do that as well to make it work within the factory. So it's like, you know, the robots making new robots. But actually, I do think that will be something that our mindset will move towards. Rather than just an average set of processes, we will actually optimize every process on the panel basis to get that tolerance really in the band and narrow that distribution curve right down. I think if we can do that, that makes your job much easier.
Much easier. Absolutely.
Yeah, and it creates those feedback loops. That means you can adjust machines for the particular products that are coming out. What I think is really exciting for you two as kind of market leaders in your space is it's a great example of how by working not just with your customers but your customers' customers, you're able to get ahead in that roadmap and really build out solutions that are ready as soon as they're ready to roll out that product. So great conversation, guys. Thank you so much for stopping by. I think this debate on 5G is going to roll and I'm looking forward to hearing more about it. But thank you very much for your time today. Thank you.
Thanks, Phil.